So why is it necessary to provide the lapping length? Because you see that in the lapping zone, my bars are something like this, okay? And it goes like this, and another bar, it will go like this, okay? So you can see that, so these are my two bars and we got concrete all over here. So when the force, let's say that the force from here transfers into this rebar, the force doesn't directly go into this rebar. So what it will happen is that the force will first go into the concrete, and from the concrete, okay, so all the way to the concrete here, and from the concrete the force will go into this rebar, okay. And if this length is not sufficiently provided, in that case the force will not adequately transfer into this rebar. Due to this reason, the concrete will have to take higher load and it might lead to the failure of the concrete. Due to this reason, this length must be provided adequately. The lap length that we provide is equal to, so lap length, this is equal to the development length. So we know how to calculate the development length, and if you calculate the development length, you can provide the same length as the lap length as well. Now let us talk about where we should lap the rebars. For that, we will talk about the lapping zones. So as I've said earlier, that so once your bar gets terminated, that 12-meter bar, you can join another bar. So this lapping you cannot provide at any location you want. Okay, so there are certain specific points in the structural member where you can provide this lapping. So let's say first we'll talk about the lapping zone in the column. So if we talk about the column, so this is a column and this is my floor slab and this is my roof over here. From here up to here, we say that this is the height of the floor, that you can see that has been marked as H. This entire height is divided into 4 equal parts. Let's say that if this height is equal to 4 meters, then there are 4 equal regions of 1 meter, 1 meter, 1 meter, and 1 meter. Okay, so this is my H by 4. This is also my H by 4. And these two combinedly give me H by 2. So the code says that you cannot provide the lap in the upper H by 4 and the lower H by 4 region. And you can only provide the lap in the middle H by 2 region. That is within this 2 meter region. Let's say that this is my 2 meter region. You can provide lap anywhere you like. You cannot provide your lap here and you cannot provide your lap here. And why is that? Because if this is your column over here, and if you see the bending moment diagram of this column, you can model the column in ETABS and apply the loads, analyze it, and if you will see the bending moment diagram, then you will see the bending moment diagram something like this. You can see that the bending moment is high in the upper region, the bending moment is high in the lower region, and the bending moment is comparatively less and zero also in the middle region only. So the bending moment is lower in the middle region. Due to this reason, we provide the lap only in the middle portion of this column. In the column, we provide the lap in the middle H by 2. And also what the code says that not more than 50% of the bars should be lapped at one position. So this is true not only for the columns but also for the beams and also for slab, also for the shear wall and other structural members. So what happens is that if you lap all the bars at one region, let's say that at this portion, okay, so you lap all the bars, then this section over here becomes structurally weak. So when the lateral load or the vertical load acts, in that case the chances are that this portion might get failed, because over there the rebar is not continuous, and due to this reason that portion is weak. So we avoid lapping all the rebars at one position.